moment of inertia. Today we are going to look on how to calculate the moment of inertia or second moment of area given as I. The SI unit meters to the power 4. Moment of inertia. So, on the cross-sectional area of the beam, when we have a beam, this is a beam, simple supported, so the beam is simple supported. On this beam we can also load it with different types of load, UDL, concentrated load. So now we are going to look on the moment of inertia, and the moment of inertia will be looking on the cross-sectional area. So this cross-sectional area in this case is a rectangle. At some other case, you may find that this cross-sectional area is a cycle. So how do you calculate a moment of inertia having different cross-sectional area? Sometimes it will be a build-up beam. A build-up beam, it means the area consists of different sheets. You have this cross-sectional area being joined together with this one to give you one beam, so that it will be a build-up beam. So this one, this area still is a cross-sectional area. So on top of this beam, you apply load. It can be a point load, or it can be also a UDL. It can as well be combined with the mass of the beam. We get that part next? Yes. So let's continue. So we are having a rectangle with the center there and the center there, centroid. So you need to choose which one will be your XX axis and which one will be your YY axis before you can calculate the moment of inertia. You get that part, ne? Yes. So when you calculate your XX, it must be always horizontal. You get that part, ne? When you calculate your moment of inertia, your XX axis must be always horizontal. So in this case, who can guess between the vertical one and the horizontal one, which one can we choose as XX?
Vertical.
The vertical one, not horizontal. The vertical one. This one, it will be our XX. This one, it will be our YY. Why so?
X is perpendicular to the side.
Sorry?
X is perpendicular to the side.
Yes. The IXX or the XX axis, it must be always perpendicular to the longest so that it can be a little bit stronger. For instance, if we are having a beam, we are having a beam in this manner, and another beam for the same beam, we put it in this manner, that long. If we apply load here, and we apply load here, which one it will be easy to bend? The bottom one, it will be easy to bend, right? So always you must put your beam in such a way that the strongest position is where you are going to apply the load. Therefore, when you find the beam or the cross-sectional area of the beam, you need to take the strongest, or you need to take the longest side. Then that longest side, it must be placed vertically. So if we were to calculate, so this one, before you calculate, you need to rotate it and you place it in this manner. Therefore, this is your XX, that will be your YY. This is your YY, that will be what? Your XX. You get that part, right? Okay. Now again, let us look on this one. This, it was only one area. Let us check when we have two areas. So between the two, between the vertical one and the horizontal one, which one can we choose as our XX axis? The vertical one. Eh? So this one, it will be our XX axis. Therefore, this one will be our YY axis. But before you start calculating, you need to rotate it so that your XX axis is horizontal. So it will be therefore this, it will be your XX, this one, it will be your YY. Are we together on that one? So this one, this is a beam. This is a beam. Do not come and say because this shape or this area 1 is vertical, this area 2 is horizontally, you will only change, you will only rotate area 2. When you rotate, there is no way you can separate these two. These two is one area built together. Somehow here I can say maybe it's being welded together or it's being joined together by the means of bolt and a nut, anything we can use to join. There's no way you can change this one without this tail. You get that part, man? Yes. So all the time when you rotate the whole shape. But you must first check, if you check this one is the longer side, this side is the shorter side. That is why this side, it must be the x-axis. X-axis is always perpendicular to the longer side. We get that part, ne? In our book, the one which we are using, open on page 147. for a non-standard beam, non-standard beams are the beams which you do not find at a hot rod or structural steel table. That will be your non-standard. A non-standard is the one which the cross-sectional area you can be mathematically calculate its area. So with these ones, you need to use the formula to calculate the moment of inertia. With the standard one, you need to read from the structural steel table. So with this one, for you to find Ixx, you need to use the formula as per the book. In the book we have BD cubed over 12. Should it happen that you forgot the formula, the one which you cube is the opposite of x. Meaning if you are calculating Ixx, the one which you need to cube is the y. And we know that the y is the vertical line. You understand that part, ne? Yes. So if you calculate Iyy, the one which you cube is the opposite of this one, which means you are going to cube the b, which is the x. After x is horizontal. Yes. So it will be EDB cubed over 12. So as you have the formulas in your book, I cannot go through them all. You can just check the other areas. Just for instance, what would be the moment of inertia when the cross-sectional is a circle? You can check from your book. Or it's a halo. You can also check there. So, calculating Ixx and Iyy, it is much more easier when you have only one area. So if you have the combination of areas, which now it becomes a build-up beam. For instance, we have the first area and the second area. So the distance from here to here is 100. From there to there is 150. This is 50 and this is 50. And let me include the other fringe at the bottom. I have added another fringe at the bottom. So this flange is the same as that flange. Therefore, here is also 100, there is 50. So in this one, we are given the dimension of this area. We are also given the dimension of this area. There is 50 as well. We are also given the dimension of this area. So if you check this area, it's a rectangle, rectangle, rectangle. So it means this cross-sectional of the beam is not standard. Therefore, we cannot read from the structural steel table. We need to calculate. So, the horizontal, that will be our XX. Vertically, our Y. So in this case, I, X, X, the total. Total, I mean for all the three areas. For area 1, area 2, area 3. How are we going to get the total for this one? We are going to take the IXX for area 1. We add together with the IXX for area 2. We add together with the IXX for area 3. In that case, we do have the total IXX or moment of inertia about XX. So now let us look only at IXX. So if you check IXX for area 1, this is a rectangle, right? So as it is a rectangle, it means IXX for area 1, it will be what? BD cubed over 12. So, in all cases, when you have a build-up beam, or you have the area which consists of more than one, when you have the cross-sectional area that consists of more than one area, you must always add AR squared. So in the case of R, other textbooks are using H, no problem. So you must always add AR. AR, this is the area. So this is the distance between the centroid and the center of the area which you are calculating. At some other case, you will find that they did not add this one. The reason they did not add this one is because R is 0. If you cannot tell that R is 0, you need to add it. You calculate it until you get 0. But if you can see from the cross-sectional area that R is 0, there is no need for you to add R. So same applies for IXX2 BD cubed over 12 plus AR squared. Sorry? R2 is 0. Yes, you are right. R2 is 0. But what about for those who are not sure about that one? So R for this for area 2, it will be 0. And we will look on that one. So same applies. IXX3, it will be BD cubed over 12 plus AR squared. You understand that part, right? So, okay. Let us check on this one. For area number 1, B, we said when you calculate XX for a rectangle, the one which you cube, it will be the Y value, right? So it means in this case, we have the Y value as 50, meaning 50 is the one which you are going to cube. The horizontal one, which it will be 100. You get the part, me? So when you come to this one, A is an area. The area, it will be 100 multiplied by what? 50. What about R? What about R? R is the distance from the neutral axis up until to the center of that area. For instance, here we have area 1. This is the neutral axis for the for the whole area, for the whole cross-sectional area of the beam. So if this is the center of area 1, how long from here up until there? That will be your R1. So your R2, this is your R3, this is the center of area 3. So how long from there up until there? That will be your R3. So this one is area 2. The center of area 2 is on the same position as the centroid. Therefore, what's the distance from here to here?
0.
Is 0. Ne? So, or you can still say, remember from the bottom up until here, that is y bar. This is y bar. So you can still calculate R1, saying R1 it will be y1 minus y bar. Again, we know that from here up until there is y1, right? Then from here to there is y bar. So if you have the total distance, then you subtract this one, you are left with that one. You get that part, ne? Yes. So your R2, it will be y2 minus y bar, or R2 is equals to y bar minus y2. You need to get the positive answer. It's either you put it in this manner or in that manner. It must give you the positive answer. But anyway, even if you calculate and find the negative answer, the square root is going to correct that negative, ne? Yes. Because negative times negative or negative square is positive. So R3, it will be y bar minus y3. We have already done the centroid. So in this case, what is the magnitude of y bar? Sorry? R1 you said is what? Is what? 125, ne? Yeah, the dimensions are in millimeters. 125 millimeters. Remember I said before you can calculate, you need to check if it's symmetrical. So if we say this one is our center, it's our centroid, is the area above the same as the area below? So because it's the same, therefore it is symmetrical. As it's symmetrical, you can take the total distance, you divide it by 2 because it's symmetrical. You get that part? And the total distance we have 50 plus 150 is 200 plus 50, which it will be 250. When you divide it by 2, you get 125. This is y1, not r1, I'm sorry. It's y1, right?
It's y bar.
No, it's y bar, eh? Yes, I'm sorry, it's y bar. That is y bar. So now we are having y bar. We need to find r1. So r1 we said is y1 minus y bar. And how did I say defined y1? Or what is our y1 in this case?
It's not from the bottom to the center of area 1, which is 225.
Sorry?
225.
225 minus 125. And what do we get?
100.
Sorry?
100.
100. So it means this is the value which you are going to substitute here, because that is under area, is under IXX1. So R2, what will be the magnitude of R2? It's y bar minus y2. And in this case, y bar is 125. y2 is what? 125. Therefore, the answer it will be what? 0. So as the answer here is 0, it's the same as not including this one. You get that part, right? Yes. So R3, it will be what? Y bar minus Y3. And the Y bar is what? 125 minus 25. And what do we get? 100. And if you check, R3 is the same as R1. Is correct, ne? Area 3, area 1 is the same as area 3. Is that correct?
Yes.
B for area 1 is the same as B for area 3, as well as D is the same. Meaning, it's either you can calculate it separately, or instead of calculating it separately, this one you combine together with that one, because everything is the same. The area is the same, the R is the same, the B is the same, the D is the same. It's either you put it this manner, or you do not multiply this by 2. You just add area 3 that other side. In anyhow, you will prefer 2. You get a partner? Okay. So let us check on this one. Yes. So we have another build-up beam here. This build-up beam, it consists of a standard area and a non-standard area. So on this non-standard area, you have 200, you also have 50 there. So the standard area, it's a channel. So on this channel, we will be using 280 times 95 times 21.8 kilogram per meter. So in order to calculate IXX total, it will be IXX1 plus IXX2. Then the IYY total, it will be IYY1 plus IYY2. So now, let us look at area 1. IXX1, it will be in brackets plus AR squared. Remember I said once you have more than one area, you need to add AR squared, which I said R. Some other textbooks, they use H, so do not get confused about that one. I'm used to R. So what about this position? If it was a non-standard, and this non-standard, it happened to be a rectangle, we were going to say is BD cubed over 12. If it was a rectangular, and that, yes, if it was a rectangular. If it was a circle, area 1, you are going to use the formula as per the textbook. But in this case, this one here, it's a standard. With the standard, you need to read from the table. So, what do I do here? I usually say this is I, X, X from the table. This T represent table. So, let us go and look for this channel. Let us look for the channel. Have you got the channel?
Yes.
Page
10.
Page 10, eh? Yes. If you look at page 10, if you look at the page 10, right top corner, you have this. They have drawn for you this one. This is Y. This is Y. This one is X, X. Can you see that one? Eh? So, this it will mean the IXX which you read from the book is as like this one. Can you see that part? Eh? So, in our case, we are having this one. Can you see? And we have this one. So, in this area number 1, this is our XX. Can you see? In this area 1, this is our XX. Ne? If you check here, our XX corresponds with what? With YY, right? Yes. XX corresponds with YY. In another word, if we were to take this one is the one from the structural steel table. If we were to take this one and we put it in the same manner which our question is being placed, it will be like this one. Y, Y, X, X. We just rotated this one. You get that part, ne? So in this case, which one should I substitute here? IXX or IYY? So in this one here, in this case, instead of substituting IXX, I will substitute I what? IYY from the table. So if I was calculating IYY, if I was calculating IYY total, what will be my IYY1? What am I going to substitute here? IX, X from the table, ne? Plus what? AR squared. And in this case, the R, remember this side we said the R is, you need to take, for you to get R1, you need to take Y bar, you subtract Y1, right? Or you take Y1, you subtract Y bar, whichever gives you a positive number, right? When you come to this one, when you calculate R, because you are calculating R looking at YY, ne? So it means your R will be, R1 will be X bar minus X1 or X1 minus X bar, depending on which one gives you the positive answer. You get that part, ne? And not forgetting, if you find it like this one, your neutral axis, it can be somewhere there, right? Your centroid. Your centroid can be somewhere there. Is the shape above the same as the shape at the bottom? So meaning this is not symmetrical. Therefore, you will be required to calculate Y bar as we were doing yesterday. So, what will be the value of Ixx2 or the formula for Ixx2? It will be what? BD cubed over 12 plus AR squared. Because area 2 is not standard. We cannot come and read it from here. So we check it's a rectangle. Because it's a rectangle, therefore we need to use the formula. Let us look on the last cross-sectional area. The last cross-sectional area, which will consist of 3 areas. I will modify on this one. So here we are having I so this one here is 200 times 50 and the I'm going to select I parallel flange, which is 305 multiplied by 102 multiplied by 28.6 kilogram per meter. So now here you are required to calculate Ixx. You are required to calculate Ixx. So how many areas do we have here? 3. The second one and the third one. It does not matter how do you choose which one is the first one, which one is the second one, as long as you do your things right. So, okay. That will mean the Ixx total, it will be Ixx1 plus Ixx2 plus Ixx3. Because we have 3 areas, right? Yes. So, let us take Ixx1. We calculate it aside. When we calculate it aside, what do I put here? Y from the table, plus AR squared. This is area 1. So which value do you get from the book for the channel? Which value? Sorry? 8, 3. 3,982 exponent -6, and the area 5,342 -3. So these values you have read them from this one, right? So the R you need to calculate, because we are calculating Ixx, meaning when for you to find R, you will use Y bar is equals minus Y1. This will be your R1. If we were calculating Iyy, we were not going to use Y bar. we're going to use X bar. What together on that part, ne? Okay, now let us look at IXX2. The formula will be IXX from the table, ne? Then plus AR squared. So what do you get for this one? In the table, what is it that you get? $54.39 -6, ne? And what will be your area? 3,639 -3. Yes. So because you are still calculating IXX, it means your R, it will be your R2, it will be Y bar minus Y2. This one is what we were doing yesterday. This two. We did this two yesterday. So now you'll just add out to calculate R2. So let us go to IXX3, which it will be VD cube over 12 plus AR squared. And what is the value of B? 200, D 50. And this one it will be 50 times 200. But remember, you need to work in meters, ne? Yes. If given in millimeters, you need to work in meters. So basically, this is how you calculate moment of inertia. You'll be required to calculate IXX and IYY. But for a simple supported beam, it always bends about XX. It's a beam. It will always bend about XX. I did draw a beam initially, which it will lead us in bending moment over moment of inertia is equals to bending stress over Y bar. Yesterday we did calculate Y bar. Today we are calculating IXX. This I is a moment of inertia about XX. You get that part, me? Yes. So this one is always the max. That is always, you always use the max. Meaning after calculating, if you're using this one, this is your center, is your neutral axis, X, from there to there, you have calculated Y bar. Meaning you still need to check how long from there up until up there. Even this one is Y bar, but this one is Y bar from the top, this one is Y bar from the bottom. So you need to check which one is greater than the other. In here, you use the bigger one. What is it? In here, you use the bigger one. Here, you always use IXX because it's a simple supported beam. That beam, it will always bend about XX. Is there any question? No question. Yes. You do not understand why didn't we use XX in here? And we are calculating IXX. Look here. Can you see this one? Again, this is our area 1, the channel. So in the channel, open this channel from your wardrobe. Sorry? It's page 10. Yes, it's on page 10, right? So, okay. just check at the top right corner. At the top right corner, you have this diagram which shows each channel, right? And here they have indicated this line, which is our YY, right? And this one here, they have indicated what? XX. You get that part, ne? So, what are we calculating here? We are calculating IXX. IXX, is it horizontal or vertical? Horizontal. So if you take this one, now you need to align with this one. Which value align with this one? The Y is the one which now is horizontal, right? And now we are using horizontal to find the solution. This horizontal, this is the horizontal one, which it aligns with this one, with the vertical this side. So that is why this side will read the vertical in order to compensate the horizontal this side. I'm not so sure if I do make sense. This T is not total. This T, I said it represents table. Yeah, and I was saying I have read YY from the table. You get that part, ne? So the total one, I'm using the capital letter T. So this one I use small letter t to indicate that I have read that one from the table. But if you prefer using one, you can write one. Yes, it's all about knowing what is it that you're supposed to substitute. Yes. Meaning this one, that is why here I wrote brackets. This one, it covers the one there, it covers the one here, area 1, it covers R1. For me, there's no need for me to go and write again 1, 1, 1, 1 after I have written it there. But if you prefer to write one here instead of T for the table, still correct. Agree? This one, you know that you need to go and take from the table. Why write table? But that doesn't dispute that I prefer writing it. You get the part? Yes. Any other question? None.